Okay, morning students. Welcome to the today's class. Today we would like to discuss about lecture number 9, unit number 1. Okay, so we would like to discuss today exclusively two's complement representation, two's complementation, related arithmetics, representations and arithmetics. Both we will look at this one. Okay. Okay, fine. In the previous class, we have seen that ninth complementation. Why we have gone for the complementation? Because when we do some kind of arithmetics, like if addition is okay, we don't have any problem. When we talk about the subtraction, it is a little bit difficulties involved in that. Okay, that is the one problem. Okay, representation, the performing the arithmetics is sometimes difficult when we talk about the subtraction. Another problem is that whenever we realize in the circuits, it is better to implement only one circuit to perform all the operations. Even if it is a subtraction, adder has to perform that one. Okay, so these are the two things that we should know. The first thing is that why we have gone for complementation I'm talking about. Okay, for better operations, for better arithmetic operations, we need this one. Complementations are required. Okay, and for better hardware realization purpose, we need to go for complementation. Okay, so therefore in this perspective only the adder is we are using. Adder is sufficient. Okay, we will look at how do we design these adders with respect to these things in the later point of time. Okay, so subtractions, especially in the subtractions, complements have a better possibility. Okay, for subtractions, complementation is best choice. Complementation is best choice. Okay, so this is what we need to understand about the complementation. Okay, fine. Okay, let us represent, as we have seen previously, how do we represent diminished radix for two's complement. Okay, we talk about most of the cases binary complements. Better we write here is binary complements. Okay, binary complements. Okay, so in the binary complementation, what we have to see, we talk about radix 2. Okay, radix 2 we talk about. Okay, so what is its r's complement and r minus 1's complement? Okay, or r's complement. What do you mean by r's complement? R's complement is nothing but 2's complement. As simple as that. It is 2's complement. What is this diminished radix complement? Which means that r minus 1's complement, right? So what is this r minus 1's complement? We normally call it as 1's complement. Okay, 1's complement, right? Fine. Let us perform the 1's complement representation and the 2's complement representation. Let us consider r minus 1's complement first of all. So here in this binary number system, it is simply 1's complement. Okay. What is the mathematical equation that we normally supposed to do for this one? Which means that 2 power base we have to consider. where power is a number of bits minus 1, okay, minus given number. This is how we have to perform the ones complement. Okay, so therefore ones complement of this represents, I can say that it is the ones complement. So if anybody asks you how do you perform the ones complement, means this is the only the procedure we have to follow. So for example 1010 I have given. Okay, so what is its complemented value for this ones complement of this number? Okay, whether it is positive number, negative number, I don't want to consider it here. Okay, but actually complementations are best suited for negative numbers only. But whatever the number they have given, if they ask you to what is the complement of this number is, how do we perform this one? So we have to consider 2 power. How many number of bits are there? 4 bits are there. Minus 1 minus given number 1010, which means that yeah, bottom only I will write. So 2 power 4 stands for, we have to consider a single one, and 4 zeros we need to consider for that. Okay, so I think, but that is what actually the meaning of this one. Okay, minus 1 that I have to write, minus 1010. So if you subtract 1 all these zeros minus 1, it becomes 4 ones. It becomes 4 ones. Then the one value is 0. So therefore it is very easy to perform the subtraction between the positive value to the negative value. Sorry, not positive value to the negative value, higher value to the lower value. We did not take any kind of borrow in this case. Okay, so the specific meaning of this statement is, it is not allowed you. So the statement meaning is, it's not allowed you to take borrow from the other thing. That's what the meaning. I'm sorry, here is the one is missed. Okay, so what is the meaning of this 2 power n minus 1? This 2 power n minus 1 makes sure that it is not allowed you take the borrow from the other thing. Okay, for example, if all the ones if we consider here, we don't want to take borrow from anything. If we take a borrow, that is a problem actually we are facing while we are talking about the subtractions. So that's it. Okay, therefore now what I have to do, I have to perform this one. Therefore this is value is 1, this is 0, 1, that is 0. Excuse me. Okay, so this is what we have to perform the ones complement of a number. Okay, so as we have discussed previously, there is a shorthand notation is also there. Okay, shorthand method, shortcut. So what we can see that whenever the people say that what is the ones complement of this number, means just simply invert bit by bit. Okay, that means complement bit by bit. Complement means opposite. So therefore complement as simple as that. Complement stands for opposite. So what is the opposite value for this one? 1. What is the opposite value for this one is 0. What is the opposite value for this one is 1. What is the opposite value? That is 0. So therefore you can see that these two are equivalent. Okay, so both are equivalent to say that. Is it clear to all of you? How do we perform the r minus 1's complement for any given number? Okay, let us now talk about 2's complement or r's complement. Now let us consider r's complement in this binary number system. How do we perform? So therefore it's simply just you take 2 power of n minus 1. So whatever the ones complement you have considered, m stands for a given number. For example, m stands for a given number. Okay, so here better you write it simply 2 power n minus 1 minus m. That's what I want to write it here. So, okay, so I think better it is not here. I think better here I can write it 2 power n minus 1 minus m. That's what we write. M is a given number. So here is this is a ones complement. This is actually says that ones complement. Agreed? Ones complement. And we have to use plus 1 to this. Now this becomes 2's complement of that number. 2's complement of the given number. The given number. Okay, agreed? Given number. So mathematically we can simplify this one because 2 power n plus 1 minus 1 will get cancelled. Okay, right? 2 power n minus 1 minus m plus 1 stands for 1. 1 will get cancelled. Therefore 2 power n minus m will be the answer for this. Okay. Okay. Now, therefore, we don't want to go for it. Just as, for example, I want to calculate. I want to calculate 101. 101 2's complement. What is its 2's complement? So I don't want to go for this manipulations. Just I will do only one thing. First, I want to calculate 1's complement. I want to give the 1's complement plus 1 I have to do. What is the 1's complement of 101? Bit by bit complementation. 0, 1, 0, 1 plus 1 you have to add. So what it is, what is it? It is now 1, 0, 0, 1 plus 1 I have added. Therefore 0, someone carry will be available. And now this is the 1, this is the 1, this is 0. So therefore what is its value of this one now? This value is 0, 1, 1, 0. That is how we have to do. Instead of taking the 2 power n minus 1, I don't want to go for those kind of procedure. Okay, just I will take the 2's complement by just 1's complement and do the plus 1 to that one. So that is how the simplest method I will follow. Agreed? So what is the procedure involved to perform 1's complement and 2's complement? This is similar to that of 10's complement and 9's complement and 10's complement. Okay, now so let us represent some numbers. Okay, the question is that, for example, if you want to represent, okay, so how do we perform? Okay, for example, representing negative numbers is very important for us. Negative numbers, representing negative numbers in 2's complement form. So we want to perform the 2's complement methodology only for performing the different applications. Why it is so? When we are realizing the circuit, we can understand this one. Okay, so first of all, you have to understand that how do we represent a negative numbers? So very important. How do we represent a negative numbers in 2's complement form? Okay, in previously we have represented the sign negative numbers in sign magnitude representation. But here, how do we represent that? Okay, so for example, I want to use 4 bits. 4 bits. Let us assume 4 bits. Okay, then how do we represent negative numbers and how do we represent a positive numbers? For example, I have a scale something like this. Okay, 0 is available, 1 is available, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, for example. Okay, so similarly, I can consider -1 is available, -2, -3, -4, -5, -6, -7, -8. Something like this. In unsigned, how many if you are taking the 4 bits, how many number of so on up to 16, 15 also will be there. -15, for example, last digit. So for example, If it is a, if I'm using the 4 bits for unsigned numbers, what are the unsigned numbers? These are all the unsigned numbers, right? These are all the 14 and 15. How many number of digits I'm able to perform, I'm able to represent? For example, I have a 4 bits in my hand. Okay. Unsigned. What is unsigned here? So these are all the unsigned, right? These are all the unsigned numbers. Okay. So how many number of digits that I can represent if I have a 4 bits? For example, I did not give this one. Okay. If I'm saying that, of course, I did not give anything here. Okay. Just simply understand. So if by using the 4 bits, how many number of digits, how many number of decimal digits I can represent, or how many numbers that I can represent? Any guess? 4 means what are the weighted values? For example, B3, B2, B1, B0, 4 bits, something like this. 4 bit I have taken. What is the minimum value that I can have? Unsigned values we talk about. 0, 0, 0, 0, right? This is the one number. Then another number, 0, 0, 0, 1, another number. Like this, how many numbers I can have? 1, 1, 1, 1, right? Agreed? Are you agreed about this one? If I am taking the 4 bits, how many possible values that I have? How many possible values? It is actually 0, it is actually 1, so on up to 15. Agreed? 0 to 50 numbers I'm able to represent. That means, so starting from 0, 1, 2, 3, if I'm using the 4 bits, I'm able to represent 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 14, 15. That means unsigned numbers. These are all what we can call it as, these are unsigned numbers. That does not have any sign for this one. For example, if you want to say there's a positive sign. The positive numbers are all we will call it as unsigned numbers. What we can call it as, it is unsigned numbers. Unsigned numbers. These are all unsigned numbers. So if you're using the 4 bits, 0 to 15, I am able to represent, right? Okay, so what is its binary equivalent for this one? 0, 0, 0, 0. As I mentioned that 0, 0, 0, 1, so on up to 1, 1, 1, 1. Agreed? Fine. So what is the range of this one we want to mention? What is this range? 0 to 2 power n minus 1. N stands for number of bits. Okay, 2 power 8 means 2 power 4 minus 1. How many? What is the value? 2 power 8. Okay, 2 power 4 minus 1. What is value? 16 minus 1. That is 15. 15 is the value that I'm able to represent. Okay, so in the sign magnitude representation, okay, in the sign magnitude representation, what we have done? In sign magnitude representation, how many numbers that we have represented? 0 to 7 only, I think. So 0, 0, 0. Next is 0, 0, 0, 1 is possible. 1, 2, 1, 0. Like this, how many number we have done previously? Up to 8 we have done. Okay, 0, 1, 1, 1. So here, what is this value now? 2 power n minus 1 that we have done. But here also what we have done, 1, if you write like this, MSB bit is equal to 1 means 0 stands represented. 1 stands for 0, 0, 1. Minus 2 stands for like this, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12. Like this, minus 13, minus 14, minus 15 only anupana. So in sign magnitude representation, what we can write it as? In sign magnitude. How many we can write it? So up to 1 only. So here is the 1, 1, 1, 1, something like this. Right. So by looking at MSB bit here, we can say that it's a negative number. By looking at 0, it is a positive number. So what is this maximum value that we have got here now? minus of 2 power n minus 1 minus 1. This is how we considered. So here, similarly, by using the 2's complement representation, yeah, how do we represent the unsigned number? How many number of digits that we can represent? Okay, please remember very carefully. Whenever we are using the sign magnitude, the 2's complement representation, unsigned numbers are as it is same numbers that we have to use. For 0 means 0. 1 stands for 0, 0, 1. 2 stands for 0, 0, 1, 0. 3 stands for 0, 0, 1, 1. 4, 5, 6, 6, something like this. 7. Okay. So 7 bit, so the 4 bits we can represent the 7. Okay. So please remember that. So all these are 2's complement representation for the positive numbers. Okay, please remember, whenever we have a positive numbers, its 2's complementation representation is not at all changed, the same value only. Okay, so therefore, what is its maximum value then? Here also 2 power n minus 1 only. But whereas in the negative, for example, how do we represent negative 0? Okay, so how do we represent this one? For example, minus 1 is there here, minus 1, minus 1, minus 2, minus 3. How many number that I can represent? Minus 4, minus 5, minus 6, minus 7, minus 8. How many represent? How do we represent minus 1? So that means it's a negative number. So we have to take the 2's complement of that number. What is the 2's complement of minus 1? So how do we represent? So for that one, what I have to do, I have to take the plus 1 related binary value I have to consider in 4 bits. What is this value? 0, 0, 0, 1. Okay, now we have to take the 2's complement of this number. Okay, therefore 2's complement of plus 1, which implies that 2's complement of minus 1 plus 1 represents minus 1. That's what important. Agreed? Minus 1 is nothing but it's a 2's complement of plus 1. What is the 2's complement of plus 1? First of all, I have to consider 1's complement, then we have to add 1. So this value is equal to 1, 1, 1, 1, something like this. So therefore, what is its value for minus 1? What is the value of the minus 1? 1, 1, 1, 1. So what is the minus 2 then? What is minus 2? What is minus 2? Minus 2 is nothing but it is the 2's complement of plus 2. So what is value then? 1, 1. Sorry. So 0, 0, 1, 0 is a value. We have to take the 1's complement of this number is 1, 1, 0, 1 plus 1. We have to add 0, 1, 1, 1. This is what the value. Therefore, this is 1, 1, 1, 0. Okay, so like this we have to mention. So what is the maximum? So of course, let us consider 0. We found that there is a problem with the 0. There is a problem with the 0. So how do we represent minus 0 then? Minus 0. It is nothing but 2's complement of plus 0. Okay, what does it mean here now? 0, 0, 0 means 0, 0 only. What is the 1's complement, 2's complement of this number? 1, 1, 1, 1. 1's complement plus 1 we have to add 0, 0, 0, 0 only. Okay, we have to take 0, 0 only. So therefore, 1's complement of this number is also 0, 0 only. But in the previous class, what we have seen that it is different. Okay, as we can see here carefully. So these are the two numbers that we have. But here we can see here is that the same numbers. Okay, now the question is that what is its maximum negative side? What is the maximum? If you are taking the 4 bits, what is the maximum digit that we have to represent? It is possible to represent. What is the value then? Next, minus 7 ante ella rastar babu. Minus 7 ante, for example, minus 7. Sorry. For example, minus 7. So for example, minus 7 is the plus 7 and the 0, 1, 1, 1. Its two's complement is 1, 0, 0, 0 plus 1. I have to add 1, 0, 0, 1. So therefore it becomes 1, 0, 0, 0, 1. Okay. Now what about 8? What about 8? So minus A stands for 1. So A minus 8 means 1, 0, 0, 0 is the plus 8. One's complement is 0, 1, 1, 1 is the this one. Plus 1 I have to add. Therefore 0, 0, 0 is the 1. Okay. So therefore this value becomes 1, 0, 0, 0. For example, minus 9. What is value? 1, 0, 0, 1. Okay. So what is this value? 0, 1, 1, 0. Plus 1 if you add 1, 1, 1, 0. So observe carefully. See here, observe carefully. Now, whenever we are talking about the negative numbers, we want to represent MSB bit must be 1. Okay, MSB bit must be 1. But if the minus 9 requires 0, MSB is 0. So therefore, by looking at MSB is whether logic 0 or logic 1, we can say that whether it is a positive number or negative number. Right? This is similar to that of the sign magnitude extension. But what we have done, the MSB bit is only meant for whether it is a positive or negative, positive number or negative number. But here the sign representation is also used for the magnitude purpose. So I will tell you what is that. So, but anyway, what we can say that. So we will go for more detail about it. First of all, up to 8 only it is possible to represent, because by looking at negative number we can say that. Okay. So what is its number then? Can you guess what is this range for this one? 2 power n minus 1. Can I write like this? I think it's 2 power n minus 1 is not 8. I think. Anyone can help me? What is this maximum value for this? Minus 8 I want to represent. Plus 8 I'm able to do it, but minus 8 I want to represent. What is this value? Minus 8. Anyone from the class? So I'm requesting you to that. What is its value? Minus 8. How do we represent? What is this magnitude representation for that? What is its range actually? I want to see the range of that one. Anyone from the class? As we have seen so many times that.
Minus 1, sir.
Babu? Minus
1.
Minus 1, it's not like that. So please remember, see here also we did mistake. Okay, here also it's not 2's complement number is not like this. 2 power n minus 1 and 10,000. As I mentioned, 2 power minus 1 I have written. 4 bits are there. 4 minus 1. What is this value? It's a 15. Is this a 15? It's not 15. It's not 15. But the uppercase is okay. For the sorry, the unsigned for this one is okay. So this is fine. It's okay. So it is correct, and this is also correct. What about this one? Minus 7 is there. Sorry, plus 7 is required. So plus 7 is required. Plus 7 means how much value that I have to write? 2 power n minus 1 only. So therefore it's 2 power 3 minus 1. That is equal to plus 7 will be the answer. Okay, fine. Now what about here now? Minus 8 is required. Minus 8 is we want to mention. Okay, but for minus 9 it's not possible. 0 is coming to the picture. But up to minus 8 only I have to mention. What I can write now? Yes, say Allah.
2 power n minus 1, sir.
Exactly. 2 power simply 2 power n minus 1. That's it. It's a negative side, we have to write negative. Therefore, what is the value of this one now? Minus of 2 power 4 minus 1. That implies that minus of 2 power 3.
3.
That is equal to minus 8. That's it. Okay. So therefore, for unsigned 0 to 2 power n minus 1, right? It is for unsigned. Very important. These are the questions you will face in interviews as well as competitive exams. Okay. Next, for it is unsigned, sorry, sign magnitude. Sign magnitude. What I have to do? Minus of 2 power n minus 1 to 2 power n minus 1, right? Now, what is the for the 2's complement? For 2's complement range anta avutundi 2 power n minus 1 minus 2 power n minus 1 minus 1. Okay, that's it. So it's very, very important to please remember this one. Okay, you please remember this ranges. Okay, fine. Now, so let us come to the point why you take minus 9 is not possible with 4 digits, right? Minus 9 is not possible with 4 digits. See here. For example, I want to consider one example. Okay, I'll take some examples. We will do it. From that, we can understand the points. So, if I say that one question, for example, what is the largest 16 binary number that can be represented? What is the question number 1? So based on this one, let us consider one example here. What is the maximum? What is the maximum number or largest number? Okay, largest number with 16-bit binary number. Can anybody guess what is this one? One in uncomplemented form, unsigned representation law, sign magnitude representation, sign magnitude. Oh my God, sign magnitude. The third one is 2's complement. Can anyone guess this question? Can anyone from the class solve this problem? I have it 16 bits are available in my hand. Okay. What is the largest number in unsigned, sign magnitude and 2's complement? What is its value? What is maximum number or largest number? Guess. See, very, very easy question this is. So the range of the numbers is represented here, right? These are range of numbers. Agreed? It's very simple. N they have given. N is 16 bits. So what is its value then? And one more thing is that they have asked only for largest number. Total range also they didn't ask. Total range means 0 to 2 power n minus 1. So what is the maximum number? Sorry. What is the maximum number? 2 power n minus 1. That's it. Therefore, 2 power 16 minus 1. What is the 2 power 16? Oh, 2 power 16 is a very big number here. Okay, we have to write that much value. Okay, similarly, for sign magnitude representation, 2 power n minus 1 minus 1. So positive sides only we need to write, right? Positive number only, largest number is positive number only I need to write. Therefore, 2 power 16 minus 1 minus 1. That is equal to 2 power 15 minus 1. Please use the calculator and do this one. Okay, so plus 2 power n minus 1 minus 1. What is this value? Again 2 power 15 minus 1. So do it. For example, instead of largest number, it is a minimum number. If you ask, what is the minimum number that we have asked? Means sign representation 0. For unsigned multiplication is minus or 2 power n minus 1, minus values that we have to write. Agreed? That's it. Let us consider another problem. Example number 2. Representation. For this is problem belongs to representation, right? Convert the following 2's complement binary numbers to decimal. Okay, so before going to that one, we'll do one thing. We take this one only, decimal numbers only. 42, 42 minus 63, minus 63, 124, 128, 124 minus 128, 133. For example, something like this. Okay, so we have to represent what the question is, that represent the decimal numbers in 2's complement form. 2's complement form. Assume 8 bits are used. How many bits are used? 8 bits are used. Please see. Very important point is that whenever we have a positive number, whenever they have given a positive number, something like this. Okay, if you're not, the sign is not given, means it's a positive number. Positive numbers, whatever the unsigned numbers are there, unsigned numbers are there, it is what we have studied, what we have learned. For unsigned numbers, the value is the same. Okay, it is equivalent to the unsigned values. Okay, what is this value then? 8 bits are kada manaki, into 2 power 8, 7, 2 power 6, 2 power 4, 2 power solution, 2 power 3, 2 power 2, 2 power 1, 2 power 0. What is this value? 128, 64, 32, 8, 4, 2, 1, right? It's weight values. 42 means how do we represent 42? 42 and antara manaki
32, 8, 2.
32, 8, 2. Remaining all are zeros only, right? 0, 0, 0, 0. So this is what the 2's complement of 42. Agreed? Because it's not negative number. For example, represent minus 63 in 2's complement. Okay, so whenever you find that a negative number, you have to take the 2's complement of the positive number. So what is this positive number? Plus 63 and teta raval manaki. I need to have 2's complement of plus 63. We need to write. It is equivalent to that of minus 63 out matter. So what is this plus 63 raval danger babu? Ekkada vadali digit 63 raval. 63 ante what we can do? What is the 64 is not required. 32, 8, 4, 2, 1. What is the value?
47.
Yeah. 1, 1, 1. Agreed? 32 plus 8, 40. 40 plus 4. 44.
47 is
40?
7.
47. How do we get this one number then? Minus 63. Agree? Allows number answer japala. ఎవరో క్లాస్ లో 64 60 minus 63 I want to represent. How do I represent minus 63 is the question. Is it possible to represent a 63 in this case now or not? Another question is 29.
Sir, we can add 2 power minus 6 and 2 power 0
2 power
minus 6.
2 power minus 6. No, it's not like that. Any other way? Any other solution? Minus 63 is required. And that means plus 63 is required. Plus 63, how do we represent? That's the question. How do I do this? అవకాశం లేదంటారా? For example, 1 1, for example, 1 1 0 0 0 0. Okay. How do these values? What is the 2's complement of this number? How do we do this? Anyone help? Any help? I need minus 63 is required. Is it possible to represent the minus 63? How do we represent? What is its value then? You please try to do this. 2 power 1, 2, 4, 8, 32, 64. Okay, so what is its value then? 128, right? Is it right that we have done so far? 2 power 0, 2 power 1, 4, 8, 32, 64, 128. So if we add these two things, 64 plus 32 plus 8 plus 4 plus 2 plus 1. What is value? 12, 14, 15, 17, 18, 19, 20, 21. 121. Okay, something is wrong in it. Minus 63 is represented in another form. Okay, so I will do one thing. To record back this one, I will do one thing. Okay. $63. Okay, so in this situation, this is how we have to do this one. What is its value for this one? 2. 2 3s, 2 1s. 1 will be the answer. 2 15s, 1 will be the answer. 2 7s, 1 will be the answer. 2 3s are 1 will be the answer. 2 what is this value? 2 1s are 0, 1 value. 2 zeros are 1 this value. 2 zeros are 2 ones are 1 both. Sorry. Yeah, this is the value, I think so, right? What is this value then? Is it clear to all of you what I have done so far? So this is what actually plus 620, 63 we need to represent in binaries. This is the form, right? What is this value then? 1 1 1 1 1 1. Okay, what is this value? That is 0. So we want to represent it in 8 bits, right? 0. So what is this value then? Can you guess it? What is this value? 1 2 4 8 16 32. So can you add all these things? I think we missed something here. That's it. You should tell me now. What is this?
Sir, 2 power 4, 16.
Yeah, we forgot. We forgot actually 2 power 16. We forgot. Yeah, that's what we forgot. This is the value. 2 power 4 is actually 16. Yeah, that's it. It is
Sir,
6.
you did not also write 2 power 5, sir.
2 power
Yeah,
5.
yeah, exactly. That's the mistake that I did. So if suppose if you're not able to do this one perfectly, come to the basics. Okay. So this is the basic actually. Whatever the thing that I have done here, that's the basic. 2 power, forgot to write 2 power 5. Okay. Yeah. So 2 power 5 is 32. 32. This is 64. And this is 128. Yes, now it is possible. Right? In the previous one, end about in the 42 kada 42 at last in the 42. Is it the right? Plus 42 at last manki 42 kavalante manki 32 and 8 42. Here is required. Here
8
is
and 2, sir.
yeah 42.
Sir, 2 power 1, sir.
Yeah, 2 power 1. 2 power 1. Remaining all are zeros. Fine. So plus 63. So we need to have 32 is required. 16 is required. 8 is required. 4 is required. 2 is required. 1 is required. Right? Remaining all are zeros. So remaining all are zeros. Okay, what is its 2's complement of this number? First, we have to take the 1's complement. So first we have to take the 1's complement. 1, 1, 0, 0, 0, 0, 0, 0. Plus 1 we add. 1. So 1, 0, 0, 0, 0, 0, 1, 1. So this is the what? The 2's complement minus 63. So therefore minus 63 representation of minus 63 is represented in 2's complement in this way. It is a 2's complement. Agreed? Fine. Now what about 124? 124. So is it a 124? Yeah, 124. How do we represent them? Any guess? 124. Can you guess what is this value? In 8 digits that I am required, it is requested that only we have to use 8 bits only. 128.
Sir, 0, 1, 1, 1, 1, 0, 0, 0, sir. 64,
I'll write
32.
here. 64, 32.
16 and 8.
Okay, 64. I'll write it here. Actually, if you are using all 64, 32, 16, 8, 4, 2, 1, what them and 127 వస్తాయి. As you can see here, it's a very simple understanding. So 63 కావాలంటే ఏం కావాలి మనకి 63 కావాలంటే జస్ట్ 32 యూస్ చేసుకుంటే సరిపోతుంది. ఎంఎస్బి బిట్ అవసరంలా. ఓకే, so if you add 32 to up to the last one, it will be 63 will be the answer. So 128 అనగానే ఇప్పుడు 128 ని 64 to 1 యాడ్ చేసాను అనుకోండి 127 వస్తుంది. అంటే 127 లో మనకి ఎంత కావాలి, మనకి ఎంత తీసేయాలి, 3 తీసేయాలా. 3 తీసేయాలంటే 2 1 తీసేస్తే సరిపోతుంది. దట్స్ వన్ వే దట్ వీ కెన్ డూ ఇట్. బట్ ఎనీవే, as we know, everyone we knows that what is the sorry, please bear some time. 2's complement of plus 123. 123 ana? So 124 is required. So 2's complement 124 is nothing but 124 only. Directly 124. What is the value? 128 is not required. 166 is required. 32 is required. Next 16 is required.
8 is also required.
8 is also required, right? 8 is also required. 4 is required or not?
Yes, sir.
Yeah, 4
Yes,
is
sir.
0 0 not required. Okay, so this is actually we can write. Then 2's complement mali 1's complement katti 1 plus 1 kattasina avasram, we don't have that one. Agreed? Okay, so therefore that's how. So therefore we can look at this MSB. This for MSB, if you observe that that is 0, it represents the positive number. You look at here, if the MSB is equal to negative, it represents the negative number. That's how we have to remember. Okay, fine. We'll do one other example, then we can leave. Okay, please wait for 2 minutes. Okay, so that it will be completed. For example, if I'm saying that 1010, for example, we take 1010, 1010, 01101, 1101, 01101. So what is its? They are represented in 2's complement number. Okay, so these numbers are represented in 2's complement representation. Then what is its equivalent decimal number? Okay, so they are represented in 2's complement. Now the question is, what is its decimal equivalent? What is its decimal equivalent? Observe that. Please remember, observe that. Here, what is the MSB? 1. That means it is a negative number. What is its MSB? It is a positive number. What is its here? Negative number. What is this? It is a positive number. Agreed? Now, how do we get magnitude value? See, the magnitude value is represented in this way. Okay, take the 2's complement of that number. Okay, 1010, already in the 2's complement only. This is already in the 2's complement only, but we want to have a magnitude value. For that magnitude value, once again we have to take it back. అంటే 2's complement నుంచి మళ్ళీ 2's complement చేస్తే what you will get? Positive value వస్తుంది. Actually it's a negative value. It is represented in the negative representation. You do once again, you will get positive value. Okay, ఒకసారి మీరు ఒక నెగటివ్ వాల్యూని కనుక కాంప్లిమెంట్ చేస్తే పాజిటివ్ వాల్యూ వస్తుంది. పాజిటివ్ వాల్యూని కాంప్లిమెంట్ చేస్తే నెగటివ్ వాల్యూ వస్తుంది. దట్స్ వాట్ వీ హ్యావ్ టు రిమెంబర్. ఓకే, so now we have to write the 2's complement of the 2's complement number. What is value? 01, sorry, 01, 0101, right? It's a 1's complement plus 1 we add. What is this value? 01110. What is this value then? It is 6. Agree? So in the previously what I have done, for example, if it is a sign magnitude representation, for example, what you can say that minus 1 stands for minus. What is this remaining? I have to consider only these 3 digits, right? Agreed? What is this value? 2 only. Okay, in sign magnitude representation, that data is -2. In 2's complement representation, that value is -6. Are you agree with me? So, this statement meeku ardhamainda babu? What is the difference between the sign magnitude representation and complementation? This is what very important for you. So please remember, it is a sign magnitude. It is in 2's complement representation. Okay, now again, so what about the next one? Okay, so 0 1 1 0 1. Okay, what is the value? Since it is a plus positive value only, this is 1 2 4 8 12 13. So it is plus 13 is answer. What are the next one? We have to consider 1 1 0 1. One's complement we have to consider 0 0 1 0 plus 1 we have to add 1 1 0 0. So it is -3. What are the next one? 0 1 1 0 1. So what is this? Complementation is not required. Directly we can do it. 1 2 4 8. So of course it is also the same number, Chana. So difference cost 1 okay, so what is value? 8 4 12 13 14 15. Okay, 15 is answer for this, plus 15. Okay, so therefore once we have a 2's complement representation, if you want to get the what is the decimal value, identify the MSB. Okay, MSB is negative or positive. Based on that one, whether we have to perform the complementation or not, we have to do. Okay, this is all about the complementation. Okay, so therefore the complement arithmetics we will see tomorrow. After that one, we will go for codes, binary codes. Okay, so do you have any doubt related to this one? Because the 2's complement representation is very, very important. So many competitive exams they are asking. So that's the reason why I put a lot of time on this one. Okay, so please understand these concepts: sign magnitude representation, 2's complement representation. How do we perform all these things? Okay, so because the time is up, we'll stop here today. And if there is any pending work is there, we will look at in the next class. So all of you, please watch your videos that I have posted there. Okay, we stop here today. Thank you very much.
Thank you, sir. Sir,
Yes.
When do we have our exam, sir?
And the 14th onwards, Amma. I think 14th onwards you'll have an exam.
No, like our subject, it is on 14th.
Yeah, our subject is I think on 14th. They told that, but exactly the time is not specified. Whether it is 14 or some other dates, they will announce.
14th on this.
14th, na?
Yes, schedule.
What about the syllabus, sir?
Syllabus is actually up to codes. Binary codes పెట్టుకుంటుంది అప్పుడు వరకు కంప్లీట్ చేస్తాను. సిలబస్ ఇంకేదన్నా అంటే యాక్చువల్గా ఇది వెయిట్ వన్ థింగ్